Hello and welcome to another Thursday edition of Innovation Experience live from St. Louis. My name is Jesse Hands. I'm pleased to bring you another great week of content and subject matter experts. Let's have a little bit of fun. There's two engineering marvels here in St. Louis. One is actually right in this building, and I'm going to get to that in a moment. The other one, as you might expect, is over my shoulder here. How about a little bit of trivia? This arch is 630 feet high, 192 meters. Can you guess how wide it is? It's the same. 630 wide, 630 high. Most people, or many people, thought this is not going to work. This has never been done before. This is the largest arch in the world. It's the largest, tallest landmark in the United States. It's going to topple over. It's going to crush in its own weight. There were a lot of naysayers. And then when you factor in at each foot, if they were not perfect in their measurements, they would not have aligned. And guess how close they had to get? 1/64th of an inch, or less than 1/2 of a millimeter. The arch would not work. Of course it did. And now millions of people visit. You can fit 160 people at the top of the arch at one time. I believe there's 36 windows. The arch can sway in the wind up to 18 inches. And I have some coworkers here that tell me when they've been up there, it's rather unnerving to feel that movement. It's such a cool, iconic memorial to Thomas Jefferson. This was for his efforts to expand the United States to the west. St. Louis was on the edge of the United States, and this was called the Gateway Arch, the gateway to the west. And one last little trivia about presidents. No U.S. president, current or former, is allowed to go in the arch. It's too much of a security risk. But one president was very insistent that he go up in the arch. No, it's not who you might think. It's Dwight D. Eisenhower. He was in town for a speech in '67. He arrived an hour early, and he insisted on going, so he's the only president or former president that's been up there. Speaking of engineering, what you're seeing now is a 60-second video installation of our dual bay data center module, which is outside. Scott Neal is actually in there standing by. He's going to be our first presenter. First, you see the removal of the single module on a very cold February day. Then you see two flatbed trailers coming with two modules. They have plywood on each side. Plywood is removed. They're put together to create the dual bay module. You know, if you're looking for something fast, you're struggling with space, the modular data center might be the answer. And we manufacture these in 12 to 16 weeks. Very flexible in size with the ability to scale over time. They're predictable. They're built in a controlled environment. Here in the States, it's in Cincinnati, Ohio. In Europe, we have Barcelona, and we do have some other locations. Now, how about that second engineering marvel I talked about? This bike was created for Schneider Electric about 10 to 12 years ago on the American TV show called American Chopper by Orange County Choppers. And it was actually designed by Schneider Electric engineers and fabricated by Orange County Choppers. It is the world's first V-twin hybrid motorcycle. And it's actually really, really impressive. It has some horsepower. It's got 300 foot-pounds of torque. It can go 500 miles without having to refuel. And I bring this up at the very end. We've got a 4-minute video that will run right after Q&A. So I don't want to keep you from the main topic. This is modular data centers. And Scott Neal is our global director of modular data center. And he is standing by in that very dual bay IT module that you saw installed. Scott, it's all yours.
Installed, the one I'm standing in. So in a bit we'll talk about this module. I'll take you to a tour through it. But before then, just a bit of housekeeping. I'll tell you about myself and the agenda and the objectives for today. So first about me. My name, again, is Scott Neal. I'm the Product and Marketing Director for our prefabricated modular solutions. I've been doing this for about 8 years and been with Schneider for about 13 years. Come from the APC side, and through those 13 years, I've always been in some sort of similar role within the data center infrastructure business. So the objectives for today, I want to make sure you guys come away with understanding the value of a prefabricated solution, why choose this, why does it make sense, understand a bit about our codes and standards, understand when this makes sense and when it doesn't make sense, and then also understand the trade-offs that we make in terms of how this solution is designed, how we create and put together a prefabricated module, and then understand where to go to get some more technical information and once you want to get started. All right. So for the agenda, we're going to start here, and we're going to go through this particular module, again, talk about some of those things I just mentioned, and then we're going to pass it over to Mike. He's in a different form factor. He's in an ISO container, and he's going to talk a bit about that. And we're going to end up back at me with the power module or power skid, and we'll talk about our power solutions, and then after that we'll be able to answer any questions that you may have. Okay? So first off, like I said, I wanted to talk about why. Why choose a module solution or a prefabricated solution? And I'll use those terms interchangeably. I like to use the term prefabricated just because it shows that we are prefabricating as much stuff as you see here in our factory. And that's kind of a key point to start on is everything you see here was installed at the factory and delivered on site. Now, we still had to make some cross connections with cables. We still had to do some on-site work. But as much as possible, we'll try to put everything in the box. And I'll talk a bit more about that here in a bit. But why do this? Why does it make sense? Why do customers deploy this? There's a lot of different perceptions out there about the value of a prefabricated solution. But I can tell you the main reasons why is because customers have some sort of business problem that this can solve. And specifically, that's usually around problems with space, time, speed to deploy, issues with repeatability. I want to put multiple solutions in several different locations, and I don't have the infrastructure in place in those locations, or the infrastructure is different at every site, and so this allows for some consistency, and ultimately that just leads to simplicity. It's a more simple solution. It's easier to install. There's still a project. There's still work to be done, but we simplify it dramatically. And those are the things. It's hard to put a lot of concrete cost value around that, but that's really where the customers have benefited with those sort of situations. And so some examples of those types of customers, we'll look at hospitals, universities, school districts, automated factories, basically any place where the space is intended for some other purpose and not necessarily a data center. It's intended for the function of that business or that entity. So hospitals frequently have challenges where they are trying to upgrade their technology, upgrade their data center, but the data center was designed in that building is no longer big enough or has enough space to support what they need, and so they need to potentially even knock down a wall, take up some lab space, take up patient rooms. And so that space is valuable, again, for another purpose. And so it's hard to financially justify. So it's just one example of space. And for them, the value of that space is more than potentially the value the data center brings. The data center is extremely important, but again, it's hard to financially justify. In addition, a lot of benefit is that the power and cooling for a hospital are designed for the patients, the comfort of the facility, not necessarily for data centers. And so being able to take that outside and isolate the power and cooling just for the data center actually has some value as well. So again, that's just one example. We can talk about automated factories and the need they have for increasing need for more compute power on site than what they originally had, or just refurbishment of the site. So focus on those reasons. That's the reason. If you have a challenge in terms of finding space or a timeline or just support, that's where this makes sense. If you're trying to compare cost to cost of this equipment versus that equipment, I can tell you roughly it's about the same. It's those other values where this makes sense. And that's a key thing to understand where this fits for you and where it doesn't. This is a tool in your tool belt. This is another option that you have, an alternative way to build a data center, but not the way. And so, and keep in mind when you're looking at your solution, does this fit or does it not fit, right? And so that's a key point. If you can answer those questions, then this makes more sense to look at, and we'll see if it's the right fit for you. So when we're talking about different types of products, I want to make sure we're clear on what we can build. Also, this goes into why, too, when we talk about the size of units or the type of customer. So we can build everything from a small 4-rack with a UPS solution called an all-in-one again, maybe that's what's going into the factory, all the way up to a larger end that could be a 1 or 2 megawatt power module or a large 100-rack data hall. Those customers are completely different. The reasons why they deploy them are completely different, but all those options are there. So a modular solution can be anything in there, and we're taking pretty much all the power and cooling infrastructure and management, switchgear, lighting, all those things that go into a typical data center space in a building, and we're prefabricating that in the factory and delivering it to you on site. So that covers why and what it is. And now let's take a quick tour through this unit, and we'll talk a little bit more about all the features in this and some of the considerations that go in and the trade-offs that we have. So first of all, this is an all-in-one module as well. And I use that term module to define that it's not a shipping container. We'll show you a version of a shipping container in a bit. And there's trade-offs between shipping containers and modules. Modules are more purpose-built boxes, let's say, right? They're wider, they're longer, they're taller than the typical shipping container. And we have more flexibility. We can get full hot and cold aisles. We can get more space. We can get more height in the room. So it's more like a typical room that you'd be used to dealing with. A container is a bit more confined, but there is reasons for doing a shipping container. So I'll leave that to Mike to talk about those. But an all-in-one typically means that we have a UPS included within the IT space. So in this particular layout, this is called a dual bay design. We have 2 rows of racks. This is actually 2 modules brought together, as you saw in the video, and you see the seam here in the floor. This particular design has a raised floor. This is not very common. We almost never have this in there. This cooling system is a perimeter cooling. You got perimeter cracks on the other side of the wall behind Don, the cameraman, and we're distributing the air through the floor and then bringing the hot air from the hot aisles back across the top, ducted back to the cooling units. So that is one cooling method. It's not the cooling method. I'll talk a little bit more about cooling in a bit. But back to the all-in-one, again, as mentioned, all-in-one is typically something that includes a UPS. In this case, we have the UPS in row with the racks. And this particular design has 22 racks. We can do this design. We've got different solutions. They're up to about 27 to 30 racks of the same general configuration. Like I said, this could be as small as a single module with 4 racks in it, down to 25 feet long, and we still have a lobby area where we were standing a little bit ago, all the way up to something like this, a roughly 20 to 30 rack solution. And then we can continue to grow. We can have 3, 4, 5, 6 modules, up to 100 racks. And so this solution can be as big as it needs to be. When it ceases to be an all-in-one is roughly around, say, 300 to 500 kilowatts is where the power starts to get big enough where we get to separate out into a different module. You start to end up with switchgear, the batteries take up more space. You start sacrificing the IT space, so we'll just break out into a separate module. But it doesn't necessarily have to be. It can be attached. It can be inside this space. So we have a lot of options. And I want to be clear with that is that this is still very much a configure to order sort of solution. We have reference designs on our website that help you, and we purposely created those for the engineering community and for the end users so that you have a starting point. You know these different sizes, what capabilities we have, what's available. Those reference designs have one lines, they have layouts, we have technical specs. We have a lot of detail for those solutions, and we'll build you exactly that. but typically it's going to be something different because of just site-specific issues, your specific design criteria, or scalability, or whatever the needs are for the future. So keep that in mind. We have reference designs. Those are the starting points. Those that get you accelerated. We can provide quotes on those very quickly, but ultimately we're going to build you something, some variation of those, or it could be a complete ground-up design, right? So, that's a little bit about the all-in-ones and the reference designs. Inside a module, typically you're going to have what you see here. You're going to have rows of racks, some sort of cooling solution. It's an all-in-one. We'll have a UPS included as well. We'll have a lobby, and I'll talk about that in a bit. We're going to have some sort of containment system. So you can see up here we have a vertical containment that's built into the module, and that's just standard part of the construction. Is you're going to have a full hot and cold aisle containment system built somewhere into the unit. It's going to vary a bit depending on the type of cooling solution, but that's always going to be in here of some sort, unless we really are building some sort of stripped down model, but typically that is a default. The type of cooling solutions. Pretty much everything that Schneider offers, we're going to be able to put into this module of some sort. Now, what makes sense depends on your particular solution, your density. So, for example, higher density solutions may go with chill water in-row units. We can do in-row DX units. This one, like I said, has DX cracks with underfloor air distribution. We may do free air wall mount DX units, right? So if we want to maximize rack space, that's one way to do it, is we'll put the cooling units along the wall on the outside, and we can get more racks in here. Now, maybe we can't get to a higher density, and that's a trade-off that we have to make. We go to a lighter cooling system, more of a perimeter. We may not be able to get the density with, say, with an in-row chill water. We can go to a higher density, right? So those are all options that are available. We can even look at third-party options if it makes sense. We're looking at, in some cases, we're looking at liquid cooling solutions going to the future and looking at how do we integrate those into a module. So there's a lot of cooling options on the table, and we'll help you select those based off of what makes the most sense in terms of what fits and what density you're looking for. And, of course, what features as well. And when I say what fits, and that's probably the biggest exercise that we go through when designing these, is trying to figure out, given your specs, what you want to build and what we can actually fit in a module. And here's one of the challenges with a module is, because we're going with a set length of module or set width, and I say set, we have flexibility to modify that as well, but we tend to try and stay into our set sizes of a 25-foot or a 45-foot long module. And that fits only so many racks and cooling units. And so we say, well, hey, I want 17 racks. And I use that number because I know 17 to 18 racks is kind of an in-between point for us. In a single module, we can get 12 to 15 racks in one side, right? So 12 to 15 gets you between 24 and 30 total. But if you get something like 17 or 18 racks, and that's not really a sweet spot for what fits in these, because you're going to either end up with empty space on one side, or we're going to have to make a custom-sized module to fit in there. Those options are available. I don't want to say we can't do it, but those are sort of design trade-offs that engineers make, and we go through with you and try to figure out what fits and what makes sense. And so that's a bit of the challenge in terms of the trade-off. You're getting something that's prefabricated, comes complete as a solution, but it doesn't always have the flexibility. Now, if you want some more flexibility, we have a solution called a modular room. A modular room is not prefabricated, but it's pre-assembled, it's pre-engineered and assembled on site. So modular room is kind of a little bit of best of both. Again, it also has some trade-offs, but it's more for putting it inside, say, a warehouse, like a room within a room. So again, we have some other options that we won't necessarily see here today, but take a look at the apc.com site, and we'll provide that website for you later, and the specific details, and it'll show you all the different reference designs, all the different options that we have. All right, so I'm going to walk over here to the lobby. I just want to show you other solution or other things that are in this solution. So we look at fire suppression control systems. You're always going to have a lobby area like this that has all the different panels and supplementary systems in here. So This particular one has an FM200 fire suppression system. We typically default to a Novec 1230. This is just an older demo, and at the time we chose FM200. But any fire suppression option is available. We'll have an optional VESDA early detection system like the one that's shown here that Don's showing. And then we're going to have some control panels. We can tie the control panel in with the EPO if we want. We can have some different control setups and configurations depending on your particular needs. And then we're going to have controls with cooling systems. We're going to have house panels, potential transformers depending on your input voltage. And again, we have house lighting, electrical outlets, and all the things you typically have in a building. And the point of that is also because we have to meet the building codes, and I'll talk about that here in a bit. As I mentioned before, we have full hot and cold aisles. This particular design happens to have the cold aisle open and in the center, but that's, again, one configuration. We can end up having the hot aisle here. So, for example, if we're doing in-row units, we might flip this configuration around, and so instead of the hot aisles being on the outside, we actually might do it on the inside and have the cold on the outside. And so we frequently change that configuration depending on the cooling system itself. We may have a door here. Again, this may be a preference where you want this area completely isolated. That can be done as well. So we have a lot of options in the lobby area. We can make this bigger. We can make this smaller. We do have to comply with codes and clearances. So we still have to have 40 inches of clearance if we have a 480 volt panel, for example. So there are some restrictions in terms of what we can fit. And again, that goes into the trade-offs we go through the design process, making sure that we can fit all the stuff in here, right? So ultimately, that's roughly what's inside a module, and what's included. If you get into a lot of details, we'll have security systems. We may have auxiliary lighting, emergency systems, access control. We're going to have some sort of management system in here. We're going to tie into all the temperature sensors. So there's a lot of subsystems in here. This is still a building. We've got room over the top of the racks for cable trays. We can add options for multiple cable trays and fiber duct as well. So pretty much everything that you're going to see in a typical data center, we're going to find in this space as well. So I mentioned codes and standards, and so I want to make sure everybody understands that this is a building. This one's sitting outside. Part of the value of this is that you can put this outside, and it's designed to go in an outdoor environment. And as a result, we have to meet the typical building codes. And so we get into seismic considerations, wind loads, snow loads. We design for all those criteria. And we have a default that we go to. So we're at 130 mile per hour wind with 150 mile per hour design point where we can jump up to that if needed pretty quickly. We can adjust to a higher snow load very easily if we need to by strengthening the module, as well as seismic. So we've designed for roughly 85 to 90% of the country in terms of North America and Canada, but we can increase the capabilities if need to. And we work with consulting engineers to design and stamp the structural drawings of this, and then work with the local consultants and AHJs to validate that we have a structure that meets their local requirements. And so the point with that also is that this is a project. There's still codes and standards that need to be met. There's still consultants that need to be involved. This is not eliminating that entire process. This is simplifying the process. But ultimately, we still have to comply with all the same things we do on a typical new building or new construction site. And we have engineers that are very conscious and very aware of all those codes. But as typical, there's nuances from state to state. There's changes with a lot more modular solutions going on around the country that the codes are starting to adjust and starting to capture some things about modular solutions and have maybe separate inspections for them. And so understanding those inspections are there and how to address those is something that we're working on as well. So again, there's nuances there, but ultimately we should be able to manage those just like anything else. But you do have some special considerations like hurricanes or tornadoes. What do we do in those environments? You typically have other things on your site, chillers, gensets, condensers, other things that also need to be protected. So typically what I tell customers is it makes sense, again, if this is a greenfield site, that you can just build, say, a block wall around all of that stuff. You have the module and the other equipment, if it makes sense. We can make the module itself more heavy duty to withstand flying debris and tornadoes and that sort of thing. But it definitely costs more to do so. It may be more cost effective to build that wall or build that structure around or get it closer to a building. When I also talk about closer to a building, that gets into fire codes and fire regulations. Again, we will look at each site individually, and this is where we get into variances of design. Each site has different issues with fire codes, and proximity to another building defines some of that. So we may have to put a 1 hour fire rating on the module if it's within 10 feet of another building. And so another example of that could change the entire solution to some degree. There's new federal energy codes that we have to comply with, actually increase the insulation thickness on the modules. And so those are some of the design changes that we're making, kind of on the fly as those codes continue to evolve. So, I just want to make sure that everybody understands that, don't worry, we've got you covered. And then also, if you have a consultant on the project, we'll work with them, and that actually helps get through a lot of the permits and the process, and we can help work with them on optimizing this design. All right? So with that, I'm going to break now. We're going to go over to Mike, and he's actually standing in an ISO container, and he's going to talk a bit about that, and I'll meet you back at the power skid. All right, thank you.
All right, thanks, Scott. Hey, listen, one thing we want to remind you of is the Q&A widget at the bottom of your screen. If you have questions or need to get further information, further clarification on something, just click that Q&A, that purple Q&A button, type in a question, it'll come right to us, and we can manage that from there and answer your questions online. Scott was talking about the modular data center part of it, the actual modules that we built that can be configured in a number of different ways to expand the size and do whatever you need to create the exact size data center that you have. But sometimes what you need is transportability. You need the availability to move it. And that's why we've got this form factor. This is an ISO container. ISO stands for International Standards Organization. It's the typical containers you would see on ships or trucks that move lots of equipment and goods. And this is kind of where prefabricated began. This is kind of where the modular data center concept began. It began e-houses, decades ago, and then moved into being able to make modular data centers within these units. There's some challenges with this, and part of it is that there's only 8 feet wide to work with and 10 feet high, and that kind of gives us some challenges. Like, as you can see here inside, I've got 3 racks here that are perpendicular to the length of the module. 8 feet doesn't give us enough room for full cold aisle, full hot aisle, full rack space. So we have to be creative. We can either mount them like this perpendicular, or we can set them in line with the length of the module. We just have to put them on things like slides where we can pull out the racks and work behind them and everything, push them back in. And we have locking rail systems that allow us to do that. One of the other things you'll notice back here is all this wiring. We've got some UPSs on the back of these here, and we're backing this up with single-phase UPSs at a 2N rate. So I've got 6 UPSs in here to support these 3 racks, and the same in the other end. On the end of this unit, you'll see we've got a DX condenser hanging here, and that's for us to provide mechanical cooling for this unit. And the nice thing about putting a condenser unit like this on the module is we don't have to pour additional concrete to set anything in place. That hanging right there gives us the opportunity really to put that in place where it is. And then the cold air blows in from the top. Now I've got this contained ceiling here where I can take the cold air across the top and then falls into. This is a hot aisle, and then we will take it out and it will come over the top, drop down into the cold aisle. So now what happens is that air is coming down into the cold aisle, going through the front of the racks, into the hot aisle, and being vented out to the condensers again on the side there. You see that we have our switchgear and our ATS in this, so all of the normal facilities you would find in a data center are installed in this unit. We've also got split racks on this side here, And what those split racks do is those give us the capability of having multi-tenants in here. So this unit is actually designed to be put at the bottom of a cell phone tower and shared by maybe T-Mobile, AT&T, Verizon, or some of the other international carriers. So this is a what we call a telecom unit, but it's just white space at the end of the day. We still have the same cooling, still have the same power support, have fire suppression and VESDA in this unit. You can see the sprinklers probably if they're in view to you there. And this gives us the capability of delivering 60 kilowatts in this particular unit here. We've got 10 kilowatts per rack on this and 6 racks on that. And we're devising this in such a way that this footprint, this 20-foot long, 8-foot module, 160 square feet, we're able to deliver that 60 kilowatts. And so it's a nice layout, nice footprint, easy to transport. Now, this application is really good for things like petrochem and mining, places where it's hard to get things to because that makes it easier to transport them. It's also good for disaster recovery because that transportability also lends itself to being able to move these from time to time. We might see these in a military application or some of those other types of remote areas where it's hard to get people and things to. So ISO containers have a great usage. They have a heritage within this, and they're really for transportability and speed rather than having the great big data centers or maybe some of the real specific stuff on white space. One last thing we do with these, we'll make these into power modules as well to address stranded capacity issues where maybe we've got too much white space and cooling but not enough power. We can put UPSs and switchgear in these and deliver some of that power distribution where maybe not have enough capability there. So ISO container, one of the form factors that we build on. Trade-offs are size and width of the unit. Okay, great. What I want to do now is I want to turn it back over to Scott. Scott, I want you to tell us all about the power skids.
All right, well, thanks, Mike. So now I'm standing in front of a power skid and just explain the difference between a power skid or a power module. The skid is an indoor solution. There's no shell on it. It's not designed to go outside. This will slide into a building, much like this kind of structure here. We bring it right through the garage bay doors. The purpose of this, say, versus a module is just more based off of preference in terms of how you're building your data center, how you want to build your electrical room. And this pretty much what a power solution is. Prefabricated power solution is a prefabricated electrical room. We're talking about UPS, switchgear, batteries, and all the connections. You could have options such as ATS, additional tie breakers. You could have transfer switches. There's all kinds of options we have. And more or less when we're looking at a prefabricated power solution, we pretty much start with your one line. So we'll take a look at the one line and ultimately draw a box around the stuff that's going to go inside this unit. Now, it's much more complicated than that, but ultimately that's the base point of which we start. So why a power skid versus a module? Like I said, it's more of a preference. A module, the difference with the module is, again, it's designed for an outdoor solution. It's going to be much like the module that we were in out with the IT racks in it, but we're going to have this equipment in instead. And that equipment will go against the wall. So we'll have more clearance internally. And so instead of having this equipment back to back, it will be face to face but along the walls. And that takes up more space. So module is going to be much wider. It's going to be probably around 11 to 12 feet wide, even a little bit wider than the IT space, again, in order to meet those clearance requirements. That does tend to change a bit depending on what country we're talking about. So when we're looking at solutions in the U.S., there's some more clearance requirements. Outside the U.S. And other parts of Europe and Asia, we can actually reduce some of those clearances a bit. So it depends on where we're at and what country, and we have to look at those on a case-by-case basis. So the power module designs, even though there's not a lot of equipment specifically in it or on the skid, there's a lot more complexity in terms of how it's designed and the variations and options that we can include. So again, I mentioned what's on it is UPS, typically LV switchgear. It could be medium voltage as well. We have done some medium voltage solutions. and then the UPS, and then the value that we're bringing with a prefabricated power solution is we're doing all those interconnections in the factory. So I don't know if Don can capture up on top, but you're typically going to have rows of cable tray above this solution where you have all the interconnections of the UPS, the batteries, and the switchgear. And ultimately the benefit is that you're bringing, once this goes on site, you're bringing the power in and the power out, and we're managing everything in between. So these could either be dropped in outside the building and lined up outside onto a very large data center complex, or slid into a space designed for an electrical room. So if you haven't figured out, these are very big solutions, right? So this is a 1 megawatt power skid. We've done solutions everywhere from small as 250 up to 2.5 megawatts. And a power module is obviously for a different type of customer than just that all-in-one module that we were in earlier. So a power module is definitely more of a cloud and service provider type solution. Internet giants, those are the customers that are typically deploying this. And the value behind this is more about the speed and repeatability and the quality it brings. Trying to reduce that variance of work on site and from solution to solution. So by prefabricating it off site, we can do a lot of concurrent work on site and deliver a repeatable solution that's been somewhat tested and then brought in on site for final commissioning. But again, speeds up that process quite a bit, and then also helps with the scheduling in terms of knowing what's coming in, when it's coming in, and how much of it is complete. So when we look at power solutions in general, as I mentioned, they vary quite a bit. You always have the same level of equipment, but the switchgear configurations can change, how we lay them out. So again, getting into trade-offs as far as what fits in a module and what doesn't fit in the module. It's not as simple as saying, okay, well, here's my switchgear lineup. I'm just going to put in a box. We actually need to look at that switchgear lineup and determine, do we really need all those compartments? How can we optimize that space to fit into, or optimize that lineup to fit into the space that we have in the module itself? And so again, part of the design considerations, things that we go through to help optimize that and make it a bit cleaner than just taking a specification and trying to turn it into a module. Typically that doesn't work very well in terms of just responding to a spec that was written for a traditional build and trying to prefabricate that. We can do that, but ultimately we'll have to make some design trade-offs and changes. We get into things like bottom feed. We can do a bottom feed solution. We can drop the module in on the incoming power, but it makes more sense to bring it in up the side and into the module instead of trying to line things up just perfectly and drop that in. That always creates more challenges on site. So we'll look at the entire site solution. We'll look at it from end to end and design the module itself to meet those requirements that are happening on site. So it's not just as simple as, okay, well, give us the one line and we'll go have it. We want to know what's going on site. We want to understand how the power is coming in, where it's coming in, and we can help optimize that design specifically based on that information. And we have an engineering team that can help develop and work with your local team on, again, from everything from small IT module up to a large power solution. It doesn't matter what the size is. Ultimately, we're there to help support and develop those solutions. Also, I mentioned different countries. I just want to make sure I'm clear. All the stuff we talked about today applies across the world. So we're not just building these here in North America. We're building these around the world, and we're familiar with the codes and standards around the world in the different countries. And we rely on our local teams there to help us guide us through that, as well as the local engineers. But we are able to design solutions that will go anywhere in the world. And again, another benefit of a module solution is that you can ship it around the world and ship it across borders fairly easily and still retain that same benefit. We have manufacturing facilities in the U.S. in the Cincinnati area is one of our main facilities, and we also have partners in other states to help us with additional workload as well as just localization. Sometimes it makes sense to build something more local to the site. Also, when we get into special considerations such as military specs, we may partner with a third-party company that specializes in building structures just to meet tempest requirements or skiff requirements, for example. So there's situations where we may partner. There's a lot of times we will build in our factory itself, Outside the U.S., we get to other parts of the world. Our main facility is in Barcelona, and we manufacture much of our products out of Barcelona for all of Europe and even parts of Asia. We recently opened a facility in India using another Schneider facility and ramped them up with the capability to do modular solutions, as well as in one of our China facilities too. So again, much like we do in the U.S., we have abilities to partner with third parties, but we have a lot of supply chain capability throughout Schneider, and we have facilities that we can utilize, and many times as we need to ramp up in an area, we'll use an existing Schneider facility to do so and train them and send people to those sites to provide that capability. So again, from a standpoint of we can provide any of these solutions globally. Again, everything from a small containerized unit of 3 or 4 racks all the way up to a large multi-module or multi-megawatt power solution. All right, so with that, I want to talk a bit about our management systems. We have, with all these solutions, we're going to try to include some sort of management platform with our EcoStruxure software. So on all-in-one, we actually default to IT Expert as our standard, and that's one of our kind of base management platforms. The cloud platform is we'll put all the hooks in place inside the module. So we'll have temperature sensors, humidity sensors, all the controls and connections to the cooling systems, the fire suppression systems, even emergency lighting, door contacts. We'll aggregate all those things with our NetBots product and then tie in together with a gateway into our EcoStruxure IT platform. We include that automatically in the all-in-one solutions. Once we get to the larger solutions, we allow it to be a bit more prescriptive. We know that you're going to want to add or tie into existing building systems more readily. You can still do that with the standard kind of package for the all-in-ones, but we know you may want to add additional features. So especially say at the power level, do we have meter breakers or not? What other features? Do we want IR windows? Do you want thermal imaging? There's all these other features that we can add in and then layer the software on top of that. So we can do all that integration in the factory to meet your requirements, or we can do much of it in terms of getting the hooks into place, the sensors in place, and then apply the software and the configuration on site, depending on, again, your needs and whether you want to tie into an existing configuration. So I want to make sure they understand that the great thing about modular, what we're bringing to the capability is not just the equipment, but also the management layer as well. And that's a key part of this, you're doing this off-site, is we can integrate so much more. And so it's more than just putting equipment in a box. It's the connections, it's the testing, it's the management system, it's all those solutions to simplify everything on site. All right? So we're going to walk over and we're going to talk to Mike, and we'll answer any questions that you may have. All right? Hi, Mike. How's it going?
Hey, how's it going? Scott, thanks for sharing this with us. So I think we're at the question and answer portion of the program right now, right? And,
yeah.
If you want to answer some questions. I think we have a few. First one came in about kind of fastening and that. How, if you have the skids or the modular solution mounted somewhere, how do you secure it when it's in an outdoor environment? I think probably both to the ground and also just how do you secure the enclosure itself?
Yeah, so really for the most part it's bolted down. So we have bolting brackets, and we're going to typically anchor to a concrete pad. It does vary in different locations and different sites, and we have in some areas where we've done, like for military applications, we've done like stanchions where it's just more temporary. But typically you're going to have a concrete pad and you're going to bolt it down to the concrete pad, and we have bolting lugs to do so. In some cases, in seismic zones, we may actually isolate the entire module. So we have done that. That's not typical, but it can be done.
Okay, all right. We're manufacturing these in Westchester, Ohio, just outside of Cincinnati.
Yeah, so I mentioned the two main locations are Cincinnati. It's Westchester, Ohio, so in the Cincinnati area. So it's one of our main facilities, as well as Barcelona is the other main facility. So those are our two primary locations. And as I said, we continue to expand from that. So looking at other countries, other hot areas where we know there's a lot of growth. And so that varies, and so we're continuing to open those up and utilize other Schneider facilities as we grow. But for now, those are the two main facilities where we'll manufacture out of.
Okay, great. Now, we talked about engineering marvels, and these are kind of mini marvels, I guess, if you will, and set up and everything. Probably have some pretty interesting installs. Tell us about a couple of those.
So, the interesting thing about modular solutions is, again, typically customers have some sort of challenge, right? They're trying to overcome something that's unique. So it doesn't necessarily have to be a unique thing, but we've had, like, one instance is a school bus manufacturer wanted to camouflage the modules because they wanted to put the data center out in this parking lot area where they're parking all the buses. And so ultimately they wanted to look like a bus. And they just asked us, can we paint it orange? And we said, well, we can actually vinyl wrap it. And I know, Mike, actually you were involved with some of that as well, right?
Yeah, right.
So we were able to vinyl wrap it so it looked exactly like a school bus. Another installation I remember is we did a small module for a research ship. And so we had to completely seismically isolate all the racks and all the equipment to keep everything from moving, because the concerns were that the ship was going to be rocking and that typically the data center infrastructure is not designed to be rolled around. So there's a lot of installations that pop up like that are unique. Rooftops, for example, or mobile locations where a common question we get is, can you move it? Right?
Yeah.
Can you move the solution somewhere else? And we can design it for it being mobile. We've had a movie studio, for example, that wanted to bring this is in the Atlanta area, bring it downtown Atlanta for filming and then be able to move it to another location later. And the idea for that was about on-site processing. They wanted to reduce the time to do the off-site or the post-editing, right?
Right.
Do it right there on site. Yeah,
right there on location, right?
And then we also have like military applications where sometimes they need to be moved as well. So it's not typical, right? Typically, we want to keep it. It's meant to be a permanent location, but it does come up fairly frequently where customers say, "Well, hey, can I move it?" Right? And so we have to design it for that purpose, but it definitely is done and has been done several times.
Well, I think Sagrada Familia is a great example too, because they're moving it all the time.
Yeah, so definitely I encourage people to look for, just do a search for Sagrada Familia and Schneider Electric on YouTube. You'll see, if you haven't been to the Sagrada Familia Cathedral, it's a fascinating site, but we also happen to have all of their infrastructure or IT infrastructure in one of our modules. And it was a construction site, and they needed to move it. So for 2 years or 3 years, it was in one location, and they recently moved it to the other side of the construction site. So a great example of moving it. Another question we get is stacking. Can you stack these, right? So another common question, you can, right? So again, we have customers that have stacked these units. We have to design it for such. But I'll tell you the trade-off with that is that ultimately, the stuff still needs to be maintainable. All the equipment needs to be accessible, and so stacking, it creates some additional challenges with that maintenance. So keep that in mind if that's what you want to do. But in some cases, it may make sense.
Good. Now, you and I started working together at Schneider here. I came into the prefab business and everything. Lots changed since I started 7 years ago. Can you talk a little bit about how we've evolved as a company, both in terms of the new things we're doing and maybe how the customers have come to accept it?
Right. So there's definitely been a big change in terms of just how the market's evolved, right? So we go back 7 years ago, it was still trying to find where this fits. We were doing power solutions back then. The power is more or less kind of stayed the same. It hasn't really changed much in terms of form factor. The adoption rate has dramatically increased. So a lot of cloud and service providers, a lot of the internet giants are looking at or are already deploying prefabricated power solutions. So that's pretty commonplace. The other solutions in terms of an all-in-one or the IT space has been developing as this drive to the edge computing and the need for on-site computing and to manage latency. And that's really been an evolution, I think, in where this is starting to shine more. Again, I mentioned early on the factories, the warehouses, things are becoming more automated, and ultimately they want that processing power on site. And it was always there, and they had maybe a rack or two here and there. Now they're looking for like a 7 or 8 rack solution to manage the data center on site. And maybe some level of redundancy as well, more UPS backup, something more robust than what they had before. And so that's a very common trend, and I think it's different now than it was 7 years ago. And just also the general acceptance that it's no longer well, let's see how this plays out and see if it works. It fits, and like I said, it fits for very specific purposes. It has its place. You can even argue it is still somewhat of a niche product, and I think that's okay because there's needs for that. And a lot of customers, even the very large internet giants, sometimes have a need for a small 3-rack data center at some location. So it fits that need, and it's no longer an experiment. This is mainstream. This is a standard product, and it continues to grow for us every year.
Good. Now, these are pretty tight spaces in a lot of cases. It's kind of compact, and that obviously we're getting a lot of bang for our buck in square footage, right?
Yeah.
So one of the questions that came in was, hey, it's great to pre-wire, it's great to have all this stuff done in the factory and everything. How easy is it to manage and change it? Maybe shipping has caused some things to come loose, maybe some climate controls and things like that over time kind of do that. Talk a little bit about what precautions we're taking to make that and how easy it is to manage that.
So one of the things you'll find, questions we get frequently is, how does this fail, or what are the problems? And so we can be honest, where you're going to find issues are really the same issues you're going to find in a typical building. You're going to see it at the doors and any penetrations in that building. As you pick up the module and move it somewhere else, you get a lot of flexing, you get things that move around, and so we'll have to adjust stuff on site when it gets there. We'll have to look at the door seals to make sure everything's connected, and we may have to come back out 6 months later and readjust things because the site may settle a bit. Again, just like any other construction site, things change a bit over time, and so we'll have to look at that. So those things are covered in the warranty, and that's part of our process. In terms of flexibility and
being able to get in and work.
So we're designing all the solutions to be maintainable. So if the things require rear access, we'll look at that. We try to make sure everything has front access. Again, part of the design trade-off process, and make sure we understand what equipment is being asked for and then how to maintain it. So typically you're going to have the same clearances that are required by code. We're going to have things that are accessible, emergency doors, for example. If you decide, hey, we want to be able to change the equipment out in the future, we can put in double wide doors for moving. There is some challenges in terms of you are looking at confined space, but if you look at a room, a typical IT room or electrical room, again, you've got a confined space is there as well. So those sort of challenges kind of always exist. I would say that there's probably a few bit more challenges because we are putting things in more confined space, but we definitely put a considerable effort in to make things maintainable and accessible. And again, we're also using equipment that is well known throughout the industry. So even third-party stuff such as fire suppression, we're using off-the-shelf components for the most part. So any maintenance guy that comes in, he's going to be familiar with what's in that unit.
Good. Now, speaking of IT rooms, one of the form factors that we have, not as popular in the United States, but certainly more popular in other parts of the world, is the modular room. Can you talk about how a modular room format might compare economically to maybe building an outdoor format or something like that?
Yeah.
How does that work?
So, the environment that we're standing in here, which is kind of a warehouse type facility, concrete floor. We're starting to see more of these kind of room within a room, or I want to build a data center in a warehouse. And there's several different applications where that's been popping up. But making utilization of empty space is one of the benefits of modular, right? Mm-hmm. So taking a prefabricated module with a very heavy-duty structure designed for an outdoor use and putting it inside a building, sometimes you're losing some of the benefits of that, or you're paying a bit more for a product that doesn't really require all that extra structure. So a modular room is probably a bit more of a benefit to that, because a modular room is an assemble on-site solution. We can still take a lot of the infrastructure in terms of the rack pods, the cooling, and everything, put it inside. But we can also have the flexibility of different shape. We can make L shapes. We can make it bigger, square. We're not necessarily confined to the tight space. So you get the benefit of not necessarily paying for all the structure if you don't need it. Again, if you're putting it into more of an unfinished space, but something still with a roof, but also the flexibility to change the shape and change the size a bit. And so Modular Room is a great product, an alternative if you need something still with the simplicity, but not necessarily all the way prefabricated. You know, it's a nice in-between alternative, and it makes sense for a lot of situations. So that's a good thing to point in terms of, you know, the evolution. We can take you through that entire evolution of, in some cases, a standard building structure may make sense. A modular room may make sense. A prefabricated structure may make sense. It just depends on, you know, the specific site. And so again, that's where that comes into play, is some hybrid of the two.
Right. Okay. Now, these things are made to last a specific time frame, or how does that work on a lifespan? I know with Sagrada, for example, they've been in there at least 9, maybe 10 years at Sagrada, being moved all the time because of all the construction going on. That's atypical, but what do we think we see for lifespan of these?
Yeah, so lifespan, I mean, we're going to design for roughly a 30-year lifespan. It's a building, right? We're building a building. We're building a steel structure, insulated panels. It's robust. It's going to last. So, but it needs to be maintained, right? You know, it's just like any building. About every 3 to 5 years, you're going to have to re-caulk some of the seams. You may have to do some painting as well. So, and then if you have a you know, close proximity to the ocean, to a sea environment, we can actually put a higher quality finish on it. But even then, you may have to do some more frequent touch-ups and things like that. So, it's a building. You got to maintain it like a building. But yes, it's built to last like a building as well. So again, if there's any problems with that, we can come out and fix those specific problems. But it shouldn't be any different than a typical building structure.
Wow, great. Okay. Well, so one of the questions we get a lot from customers, and you and I have done these time and time and time again, but folks want to know, can they have a private showing, a real in-depth deep dive, virtual like this, or even come in when everything clears, can come in and see that? Can they get a private viewing like
so
this?
I definitely, you know, customers are always welcome to schedule visits to our factories. So the Barcelona and the Cincinnati factory are open. Now, you definitely need to talk to your local salesperson and set that up. But that is an option. You can always come to the IEBC, right? This facility is available as well.
Always welcome.
And there are other showcases around the world. But for the most part, those 3 areas, IEBC, and then Barcelona and Cincinnati, are the 3 main locations where you can go see this stuff in action and actually, you know, walk through it, touch and feel it. And with the benefit of the factory is, depending on what's being built at the time, you know, you could see, you know, a lot of different solutions.
Right. And just let me build on that. Within the IEBC, of course, not only do we have prefabricated data center modules, we have power systems, we have our EcoStruxure data center solutions room with all of micro and row and pod and even modular solutions here as well, and all kinds of other different things you can see. So we can bring you those virtually, just like we're doing here, and we can also take you to take visits once we open back up again. So, okay, great. Well, listen. This has been a great day. Thank you, Scott, for coming and working with us on this.
No problem.
Technological marvels, mechanical engineering, everything you can imagine is here at the IEBC, here in St. Louis and everything. We talked about the motorcycle at the beginning of the show. There's a short video at the end here that talks a little bit about how the motorcycle was made and all the development and the engineering in that. Remember, next Thursday, we have another end user session at 9 a.m. Eastern, 2 p.m. Eastern. I don't want to do 2 a.m. Eastern. I don't think anybody would be up for that. But 2 p.m. Eastern, just come back and join us for the next one. And let's roll that motorcycle video. Thanks a lot.
Thank you.
When it came to designing the power behind the machine, Schneider Electric opted for not 1, but 4 modes of energy consumption while cruising. All 4 modes of operation can be utilized either automatically with the throttle or manually with the touchscreen. For example, The series hybrid gas mode starts with the gas engine, which turns motor number 1, the generator, creating AC power for inverter number 1. This inverts the AC power into DC power, which charges the batteries and powers motor number 2, driving the rear wheel. In this mode, the engine creates all the power needed to drive the rear wheel without using any battery power, so it maintains full battery charge. These multi-mode operations allow for user customization and make the most of your energy. Schneider Electric's Programmable Logic Controller, or PLC, continuously manages energy supply and demand and prioritizes energy needs to achieve the greatest possible efficiency. Schneider Electric's electric vehicle smart charging station provides a smart grid interface, measuring the energy coming into the bike and providing energy reporting and monitoring. APC by Schneider Electric's Net Shelter perforated vents are used to create stylistic lines, while in the data center, they're used to provide maximum airflow to cool your critical IT equipment. Square D by Schneider Electric's light switches come from one of the most trusted names in electrical distribution, power, and control. These switches are used to power the LED lights and headlight. Making the most of your energy while cruising is made possible by Schneider Electric's touchscreen dashboard, allowing for active energy management. Schneider Electric's unique energy management dashboard gives you a consolidated view of your energy usage. The main page display shows your fuel level, battery condition, power mode, engine RPM, drive RPM, and cruising speed. It also allows you to start your engine manually and see your rear camera view. From this view, you can press the status button to go into your status screen. The status screen contains even more detailed information about the bike, including throttle position, carb target, rear motion RPM, and engine RPM. From this screen, you can also enter the camera screen, where you can switch to a front camera view to capture images or sort through your image library. Schneider Electric's biometric recognition starter uses state-of-the-art fingerprint recognition technology to ensure maximum security. Only registered users can access the machine. We've included an emergency power off, or EPO, safety switch from APC by Schneider Electric and used it as the kill switch, because whether you're in the data center or cruising down the road, safety is king.